Okay, this is number 35 in section 8.2, L'Hopital's rule. And the difficult thing about this one that was pointed out by someone is that we have these logs in here. So if we take the limit initially straight away, we're going to get the limit as x goes to infinity of log base 2 of x, of course, is going to be infinity, over the log base 3 of, and it's going to be infinity as well. And so this is an indeterminate form. And we could go straight to L'Hopital. But first, what we're going to do is we're going to go ahead and use this change of base formula. So in this change of base formula, if you have a log base a of the argument b, you can change that to log b over log a, like log base 10, or natural log b over natural log a, or log base 2b over log base 2a. But we're going to choose the base to be e, so it's natural log of b over natural log of a. So I'm going to rewrite this using that. So it's going to be the limit as x goes to infinity still of the natural log of x over the natural log of 2, all divided by the natural log of x plus 3 over the natural log of 3. And of course, I could reciprocate this a little bit and see what I end up with. So that's going to be equal to the limit as x goes to infinity of the natural log of x on the top over the natural log of x plus 3 on the bottom. And then, of course, this natural log of 2 is going to go to the denominator, and this natural log of 3 that's in the denominator of the denominator will come to the numerator. And so I'm going to do that so that I'm going to have times ln of 3 over ln of 2. What's nice is now this is just a constant. And so because this is just a constant, we don't have to worry about taking any limit with that. So that's going to be equal to ln of 3 over ln of 2 times the limit as x goes to infinity of the natural log of x over the natural log of x plus 3, which of course is still, when I'm evaluating that limit, I would still get infinity over infinity, which is going to be an indeterminate form. And so now I'm going to use L'Hopital. So I'm going to L'Hopital. And I'm just going to leave this constant out front. I don't need to do anything L'Hopital with that because it's just a constant times the limit. So I'd leave that out front. And so then it's going to be the limit as x goes to infinity of 1 over x over 1 over x plus 3, which, again, I think at this point we can see where we're going. But natural log of 3 over natural log of 2 times the limit as x goes to infinity of x plus 3 over x. And then for this, you might be tempted to say infinity over infinity again and do L'Hopital again, but remember, just like it's just end behavior. And so we know that this is just the natural log of 3 over the natural log of 2. And we know that this limit here, we know that that limit is just 1. It's the end behavior of the function. Okay? If this had a 2 here, the limit would be 2. If this had a 2 here, the limit would be 1/2. If this was an x squared here, the limit would be 0. And we don't need to take L'Hopital to figure this out. And so then, of course, our answer is just that the limit of our function that we were given is just the natural log of 3 over the natural log of 2.